So this is an overview of the periodic table. It's mostly about vocabulary. You've been given a blank one, and as I write these things down, I'd like for you to fill in the blank table so that you have it to use for your notes. Then there are a couple of activities in Google Classroom to support the information that I share here. And as you do that, you'll become more familiar with element symbols, with element names, and where they're located on the table. So I'm starting by drawing this little stair-step line. If you've noticed on your periodic table, it exists there as well. It exists whether you notice it or not, but it's there. All right, so these elements that sit on this line, there's boron sitting here and silicon here, and germanium sits underneath that. Next to germanium is arsenic. Arsenic is a very poisonous element. There's a play called Arsenic and Old Lace about two old ladies that were taking people out of their miseries by giving them arsenic. I was in that play once. Then we have also underneath arsenic we have antimony, Sb. Next to antimony is tellurium, and then polonium sits underneath that. So these guys have a special name. They are called the metalloids. So what metalloids do is they act like metals, but they also act like non-metals. And I thought I'd show you a picture of the most famous one, perhaps. And that's probably silicon. So this is what silicon would look like if I can get to drag onto my screen right there. So you see how it's kind of shiny, but yet if you hit it with a hammer, it just shatters like this. Little pieces like this, but it conducts electricity also. But it's really easy to control the conduction in silicon. And you can also structure it easily with some impurities that make it conduct better or worse, depending on what you want to have happen. So consequently, it gets used in computer chips because computer chips require real specialized control of electrical current. And there's even a whole an area in California that's named Silicon Valley. You may have heard of Silicon Valley before. This is California. It's a long way from St. Louis. St. Louis over here. Way over here. There we are. We love it. And you come in on San Francisco, that's where Silicon Valley is. You see this little light area here, that's lowland. Green is higher elevations. So this is the valley. And San Jose is kind of at the heart of it. For those of you who have Apple products, you may have noticed something called Cupertino. They sometimes talk about Cupertino. And here's a little picture of that. This is the Apple headquarters in Cupertino. Of course, you also have Facebook, Google, and many other high-tech companies house themselves in Silicon Valley. So famous it's named after one of the metalloids. All right, so that's those are the metalloids. They separate metals from nonmetals. I'm going to put a few element symbols over here. Here's one. We'll put iron in over there. Iron has the chemical symbol Fe. Here's one that you may know is Cu. Stands for copper. And you may have heard of zinc. You might know about silver and gold. So silver, gold, chromium over here. I'm hoping that these names are making you think of metal things, metallic things, because metals exist on the left side of that little stair-step line. So all this area over here, metals. Okay? That means on this side, you have non-metals, things that are not metallic. Things like stuff like carbon, like a piece of charcoal is not metallic. Or oxygen is a gas, sits right there. Sulfur we looked at earlier this year, that yellow powder, certainly wasn't metallic. Things like that are non-metals. So metals on this side, non-metals on that side. Now, horizontally on the periodic table, just generically, each row is called a period. The reason it's called a periodic table is because the properties of the elements repeat periodically. Like if you run through here and you get to this element and you come back, Turns out that this element has very similar characteristics to this element. So there's periodic repetition. That's why it's called a periodic table. Sometimes we call these horizontal rows series as well. So if I said, find me an element in the fourth series, you go 1, 2, 3, 4. Chromium would be an example of an element in the fourth series, or iron, or copper, or zinc. The vertical columns have names also. We call them either, I'm turn it sideways a little bit, we call them families or groups. So if I said pick an element from group 1, you'd be some element in this column. Group 2, group 3, and so on. Historically, there's been a little bit of change over the years in terms of how we talk about the groups, but right now the most favored convention is 1 through 18. All right, so this would be like group 18, 17, 16, 15, 14, 13. The columns, some of the columns themselves, some of the families have their own names. This column is called the alkali metals. I'll try and change the colors up to help you sort things out. So this is called the alkali metals. No particular purpose of the colors except for to help you differentiate different ideas. These are called the alkaline earth metals. EARTH metals. All right, I need to maybe point out to you that there is one element over here that's kind of a special case. Hydrogen is on the metal side of the periodic table, but it is not a metal. But chemically, it fits a little better over here because it has one electron in its highest energy level, as do the rest of the elements in this column. And even though it's not a metal, when it's in its solid phase, it does have some metallic properties. All right, everything else on this side is metals. Okay, down here there's another little group of metals. It's not really a group, but there's an area down here. These are called the rare earth elements. And rare earth elements, really, there's some up in here that are also categorized as rare earth, but generally we call them down here. Lanthanides and actinides. And those are elements that they're called lanthanide and actinide because if you look at our normal periodic table, looks like this. Notice the first element in this row is lanthanum, and the second element is actinium. Rare earth elements are trace metals. There actually are quite a lot of rare earth elements in the on Earth, but they have to be mined, and it costs a lot of money. And so right now, the primary country that mines them is China. So it's important to have good trade relations with China if we want to use them. And we use the rare earth elements in specialty applications. And you can research that on the internet if you want to. But we use them for a lot of electronics and such, and they're imperative that we have them. But they are not real noticeable. We just take them for granted. If we don't have them, though, then we don't have the electronics that they help make. All right, so those are rare earths and lanthanides and actinide series. Then moving over here, we have another group of elements called the halogens. Has a special name. And then this column is called the noble gases, because noble gases, they just don't interact with other things. They kind of stay to themselves like royalty. And the reason for that is their S, their sunny room, and their pink room are full of electrons. And so there's no room for any other electrons, so they don't interact with other things. Okay, now all of these are nonmetals, but this family of nonmetals has a special name, the halogens, and this family of nonmetals has a special name, the noble gases. Okay, I think I need to tell you this. almost forgot. This group of metals in here is known as the transition metals, as you're moving from metal to non-metals, transitioning, if you want to think of it that way. Now, I want to remind you that in the sunny room and the pink room, remember those rooms? And we had this little rule here. We said that the number of orbitals, or beds, in all the sunny rooms was 1. And that one bed would hold 2 electrons. All the pink rooms had 3 beds. And the 3 beds would hold 6 electrons. So you remember this: sunny room, pink, 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 3 beds, 6 electrons, single, single, single. So if you put electrons in one at a time, then they pair up as you begin to fill them. Then 3rd floor sunny room like that. So the sunny room has 2 electrons, the pink room has 6, 2, 4, 6. The dark room, when you get there, has 5 beds, and each bed can hold 2. On this sheet, the darks had 5 beds. Each bed holds 2, so that makes 10 electrons. So if you look at the periodic table, I think it's kind of interesting that this area right here is 2 columns wide. So I'm hoping you see that that corresponds to the sunny room. So I'm going to put an S right here. And over here, this area is 1, 2, 3, 4, 5, 6 columns wide. That's where the electrons are filling in the pink room, the P sublevel. Then a dark room, remember the dark room had 1, 2, 3, 4, 5 beds, 10 electrons, so you'd expect this area to be 10 columns wide. So we call that the D sublevel region. So the transition metals are in the D sublevel block. Let me say that again. The transition metals, you could say, are in the D sublevel block. And then down here, if the sunny room had 1 bed, and the pink room had 3 beds, and the dark room has 5 beds, how many beds would be in the fine room, the F sublevel? 1, 3, 5. What's next? And so each bed holds 2 electrons, so 14 wide. And that's what you see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 wide. So this area is the F sublevel block. So the periodic table has 4 sublevel blocks on it: the S, the P, the D, the F. After you get so that you are more familiar with it, I would be able to say something like 3P3. And you would know you're in the 3rd series, 1, 2, 3, in the P sublevel block over here. And there's 3 electrons, 1, 2, 3, so we'd be talking about this element right here. And that element is phosphorus. So 3P3 is another way to code for phosphorus. Okay, so I hope that gives you, my goal is to give you a little bit of overview of terms that we use when we talk about particular areas on the periodic table. We've talked about metals being on the left, nonmetals being on the right. Metalloids are the dividing line. Metalloids act like metals, but they also act like nonmetals. They have properties of both. The one further to the right would be more nonmetallic. The one further to the left would be more metallic, but they still have both characteristics. So nonmetals, metals, metalloids. Some of the metal families we talked about, we have the alkali metals, which includes sodium and lithium and potassium. The alkaline earth metals, which consist of magnesium and calcium and barium, that some of which you may have heard of. The transition metals. It's maybe interesting to note that in the lab we did with the spectrometers, that the colors of the solutions were caused by elements from this area. We had potassium chromate, so there's chromium. We had potassium permanganate, that's manganese. We had copper. Nickel sits right here, nickel sulfate. What else was in that lab? We had iron 3 nitrate, so that was another one. And then cobalt is element number 27. It sits right here, cobalt. So these 6 elements created the colors that we saw in the spectrometer lab, where we measured the absorption of light by the electron. Remember, the electron absorbed light. Here he sits in the nucleus. He's sitting right here, sitting away from the nucleus, I mean. When the light hits him, he moves away from the nucleus further, and that absorbs energy. We didn't see that light. So since we don't see that light, we see all the other colors And that's why the green ones were green, the green liquids are green, because green did not get absorbed. All right, so I'm getting off task. We talked about lanthanide and actinide series, the halogen family and noble gas family over here, and then we talked about the S, the P, the D, and the F sublevel blocks on a periodic table. All right, I'm going to stop the video there, and you have a Google Classroom activity. The Google Classroom activity will draw on what we just talked about here. I might take just a moment to show you that in Google Classroom, this will take me just a second to pull up. It's coming on my computer. This is where I should be telling you a joke to fill in the time. So if I pull in the classwork section here, these are the things, I haven't assigned these yet, but in this first region of the periodic table, there's a little overview here of the things that we talked about. And so there's a little video you can look at that'll kind of show you some of the words that we talked about, transition metals and so on. And then there's a quiz over that, and this is one of those quizzes you can do as many times as you want to. Get a good score and send it in. And on this one, it's another kind of similar thing. Get it done, give me a screenshot. This one is a little bit different because it gives you an opportunity to drag and connect things, so it's a little different. So lithium is an alkaline metal, you connect them like that. Bromine is a halogen, so you go up here like this. That's how that works. If I submit it like that, it won't let you do it until you complete the question. But you can skip it and come back to it. All right, so these are things that will help you, make you think about these words and use them. And if you use the words, then you get more familiar with them. All right, so I hope you have a good day, and I'll see you on Tuesday when I get back.